So hello and good morning to everyone. So our today's lead code question is 3120, which is count the number of special characters part 1. So basically in this question we are given a string named as word, and it is given that a letter is called special if the letter appears in both lowercase and uppercase in the word, right? And what we need to do is we need to return the count of special letters in word, right? So let's see an example to get the question more clearly. So here our word is this. So if we see, we have small a, we have capital A, we have small b, we have capital B, like we have small c, we have capital C. So all these three letters are present in lowercase as well as in upper case, so they are special. So if we see the count, so we have three special letters, so our output is 3. In second example, we have A, we have B, we have C, but we don't have any of these characters in capital letters, right? None of them are in capital letters, so our count of special is 0, so 0 is our answer. So let's see the constraints. So our word length is 50, and word consists of lowercase letters and uppercase English letters. So we will be discussing two different approaches. The first one is frequency counting and the second one is bit masking. So first let's start with frequency counting. So what we'll do is, so we take a hash map, and whenever we get a character, whenever we get any character, we just increase the frequency of that particular character in the map, right? And then what we'll do is, so suppose we get small a, then we check whether capital A is already present in the map or not. So suppose if it is already present, then see, we have small a, we have capital A, that means this is a special letter we have, right? Or the other case can be, if we are currently at capital A, then we see that whether we have small a or not in the map. So if this is not present, then we skip that part, right? So this way we'll be checking. If we have small b, then we check for capital B. So this way, if we have one letter of the pair, then we check for the respective other letter of the pair, right? But in this approach, what we need to do, we need to avoid the double counting. So let's see an example to get how double counting. So suppose here we have marked in the map that frequency of capital A is 1, then we come at small a, and we check for small a, does we have capital A in the map? So it gives us yes, so we increase our count by 1. Then again we get a small a, and again we check for capital A, then we have made the count as 2. So if you see, we have double counted the small a, right? So what we need to do is, we need to avoid this double counting, and for this what we can do is, we can use a array. We use an array in which we store the letters that we have already counted or seen. So once we counted small a here, then we mark small a as true, that we have already counted this letter. So when we come here, then we check whether small a is already counted or not. So we see small a is already counted, so we don't count it again, then our count will be 1. So this way we can use an array to avoid the double counting. So if you see in this approach, our space complexity will be, so big of 52 for the hash map, because small a to small z 26, capital A to capital Z 26. So in the for the hash map, our space complexity will be big of 52, and for this array, for avoiding double counting, we have used an array that will store the letters small a to z, so that is big of 26, right? So can we do it in lesser space? Yes, we can do it even in lesser spaces. So for that we will be using bit masking. So in this we basically maintain two integer variables, lower and upper. Now what these variables do is, so lower will store which lowercase letters appeared in the word, which lowercase letters appeared in the word. Similarly upper will store which uppercase letters appeared in the word, right? So for lowercase letters, for small a, it will be represented by bit number 0. For small b, it will be represented by bit 1 in the variable lower. Similarly z will be represented by bit 25, right? And similarly for uppercase letters, these will be uh, shown by bits in the variable upper, right? So suppose at any point we have the lower variable as 100. So that means this is 0th bit, this is 1th bit, this is 2nd bit. So that means a, b and c, that means c is present in our word. So this way the bit will show whether any character is present in the word or not. Now the next thing, how we will mark a character. So suppose we get a character, let's say ch. Now how we will mark this character in lower or upper, right? So suppose we get a lower character ch, then we need to mark it in the lower variable. So how we will mark it? So first of all we need to find the position of its bit, position of its bit, right? So as we have already seen, a is 0 bit, b is 1 bit, right? So what we'll do is we need to find for character. So if we do ch minus character, ASCII value of ch minus ASCII value of a, it will give us the position, of that bit. And then what we'll do is when we left shift 1 by that position, which is ch minus a, position which is ch minus a, that is character minus a. So we have set that bit to 1. So basically left shifting means multiplying by 2, right? So now the next thing what we need to do is then we do OR operation with the lower variable if that bit is in lower case. So let's say if you have character c, then when we do c minus a, we get 2, then when we left shift 1 by 2, when we get left shift 1 by 2, basically then we get 100. And then when we do lower or equal to 100, then the third bit, sorry, this 0 1 second, if we start with 0th bit, then it will be the second bit. If we start with 1, then it will be the third bit. Then this bit in the lower will be set to 1. That means that which will show that c has present in the word, right? So now after iterating over the string, and marking the presence of characters in lower and upper, now we need to find the special characters. So special characters are those letters for which there's smaller and lowercase and uppercase both are present. So that means the bit the ith bit in both should be set to 1, right? If we need the ith character as a special character, suppose ith character is a special character, then the ith bit in lower and ith bit in upper both is set to 1, right? So if we take and operation of both lower and upper, then it will return only those bits, which in which are set to 1 in both lower and upper, right? So and operation will return only those bits which are set to 1 in both and upper, that means which are present in both lowercase and uppercase. And we also need those bits. So now in common variable we have those bits, we have those bits which are present, which are present in their lowercase as well as uppercase. Now we need to count these bits. So for counting these bits we will use the built-in pop count function and pass our common variable. So what it will does is it will give us the number, it will give us the count of bits and which is the number of special letters present in the word, and that is what we want. So let's move to the code part. So in code part we have taken two variables lower and upper as we have discussed, and then we have iterated over the string word, and then we check whether our character is lowercase, then we mark the bit in the lower variable. If our character is in uppercase, then we mark the bit in the upper variable. Once we process the whole string and mark all the bits, then we need to find all those bits which are present in both lower and upper. So we take AND operation. So it will give us a it will give us all those bits which are set to 1, which are to set to 1 in both lower and upper, right? And then we need to count the number of set bits. So we have used written built-in pop count in the common variable. So it will give us the number of special letters, and like that's our code. So I hope I'm able to explain you the solution properly. So if you like the video, please make sure to like, share and subscribe the channel. Thank you.